Today's lesson is 3-5. We're going to solve inequalities with variables on both sides. So that's also our objective, is to solve inequalities with variables on both sides. This is very similar to what we've been doing in 3-4, with the exception that they're going to be x's or other variables on both sides of the equation. All right, go ahead and write down number 1. And go ahead and at the top of your notes, make sure you write down 3-5. Solving inequalities with variables on both sides. That way you have this titled. Okay, so number 1 says 3x is greater than 8x plus 10. We're going to go through and solve this pretty much the same way we do if it was an equation. Okay, so we have variables on both sides, so I need to get the one from the right to the left. So I'm going to subtract 8x from both sides. And I get negative 5x is greater than 10. Now I need to move the negative 5, so I'm going to divide both sides by negative 5. Now this is where inequalities differ from solving equations. Whenever I multiply or divide by a negative number, I have to flip that inequality symbol, so that inequality symbol is going to turn around, and it's going to go from greater than to less than. So x is less than negative 2. So now that I've solved it, I'm going to use the same steps that I've used for the last couple of days. I'm going to solve it, set it, graph it, and check it. So now I've solved, so now I'm going to set using my braces or my squigglies and my x such that. So now I've solved, set, now I'm going to graph it. So again, just like what we've been doing, the negative 2 is going to go in the middle, and I'm going to have two numbers less and two numbers greater. So it's going to go negative 4, negative 3, negative 2, negative 1, and 0. Be careful, negative numbers do go opposite of positive numbers, so be careful when you're making your number lines. It's going to be an open circle on the negative 2 because there is no extra mark here. Since there's no extra mark, it is an open circle. And then if I look, this arrow right here is pointing to the left. So I'm going to shade to the left because all of my answers are numbers that are less than negative 2. So negative 3 could be a solution, negative 4 could be a solution, and so on out that way in the number line. So I've solved it, set it, graphed it. Now I'm finally going to check it. Again, I'm not going to check with the negative 2. I'm going to check with the number that's in the shaded region. So I can check with negative 3, negative 4, negative 5, or anything on down from there. I'm going to choose to check with negative 3. And the reason that we choose to check with a number in the shaded region is to make sure that we've shaded the correct direction, because that's one of the most common mistakes that we make. So again, I'm going to go back to the original equation, just like I always do when I check. And instead of x, I'm going to plug in negative 3. And I'm going to see if this turns out to be a true statement. 3 times negative 3 is negative 9, which is greater than 8 times negative 3, which is 24 plus 10. So I have negative 9 is greater than negative 14. And that's a true statement because you would much rather owe somebody $9 than to owe them $14. So that checks out. So now I've solved it, set it, graphed it, and checked it. Make sure you have all of that down before you move on. All right, number 2, I'm going to go ahead and show you on notebook paper. So go ahead and write down number 2. It says y plus 18 is less than or equal to 10y minus 9. And again, I'm going to solve this the same way that I solve regular equations. I have y's on both sides. So I'm going to move the one from the right to the left. It's positive 10y, so I'm going to subtract y, or minus 10y, from both sides. I'm going to only subtract it from other things that have a y. So right here it's going to cancel. And here I'm going to put a 1 in front of this y if nothing's there, so that I know that that is 1 minus 10. 1 minus 10 is negative 9, so that's negative 9y plus 18 is less than or equal to negative 9. Be careful with this, it does say minus 9, so that gets brought down as a negative 9. Now I find my y, which is right here. I need to move the 18 and I need to move the negative 9. So I'm going to move the negative 8 or the 18 first. It's positive 18, so I'm going to subtract 18 from both sides. So I subtracted 18 from both sides. I brought down my negative 9y is less than or equal to negative 27. Because negative 9 minus 18 is negative 27. Then I'm going to divide both sides by negative 9. And right here's where we have to be careful. I just divided by a negative number, and we kind of sometimes have to stop and think about that. We get in such a hurry, in such a rush with solving, that we forget about that step where if I multiply or divide by a negative number, my inequality symbol has to flip. So here I did multiply by a -9, so that inequality symbol is going to flip around, and instead of being less than or equal to, it's going to be greater than or equal to. And -27 divided by -9 is a +3. So y is greater than or equal to +3. Now I'm going to go ahead and set it. I'm going to put my braces and my y such that in front. So now I've solved it, set it. Now we're going to graph it. Again, my 3 that I got is going to go in the middle, and I need two numbers less than 3 and two numbers greater than 3. So I'm going to say 1 and 2 and 4 and 5. Then I'm going to look, there's an extra mark underneath my greater than symbol, so it's going to be a closed circle on the 3 because 3 is actually a solution to this one. And then if you look, the arrow is pointing to the right, so I'm going to shade to the right. I'm also shading to the right because of the fact that it says that all my answers are numbers that are greater than 3. So I'm going to shade the region where the numbers are greater than 3. So now I've solved it, set it, graphed it. Finally, I'm going to check it. Again, go back to your original equation for the check, and you can check with 4 or 5 or any number greater than 3. I'm going to choose to check with 4. But before that, I'm going to go back and rewrite my original problem before I did anything. And then instead of y, I'm going to put in a 4. So 4 plus 18 is less than or equal to 10y times 4 minus 9. 4 plus 18 is 22, which is less than or equal to 40 minus 9. So that makes it 22 is less than or equal to 31, and that is a true statement. So it checks out. 22 is less than 31. So make sure you have the solve, set, graph, and check for this one before you move on. All right, go ahead and write down number 3. It says 6.7n minus 4.1 is greater than 2.7n minus 3.1. Again, this one has decimals, but it's not in any way going to change the way that we work the problem. We have n's on both sides here, so that's the first thing I'm going to do is I'm going to move the n's to one side, and I'm going to subtract 2.7n. And especially here, I always like to go from right to left so that my n is always on the left when I'm finished. That way I don't have to flip anything around for my set notation. And 6.7n minus 2.7n gives me 4n. So 4n minus 4.1 is greater than negative 1.3. Then I'm going to move everything away from that n, starting with the 4.1. So I'm going to add 4.1 to both sides. And I get 4n is greater than 2.8. Then I'm going to divide both sides by 4. And n is greater than 0.7. So n is greater than 0.7. So I've solved it. Now I'm going to set it with my solution set and my n such that. So I've solved it, I've set it. Now I'm going to graph it. Again, my 0.7 is going to go in the middle, and I need two numbers less, so I'm going to say 0.5, 0.6, 0.7, 0.8, and 0.9. I'm going to put an open circle on the 0.7 because if you notice, there is no extra mark here. So it is open, meaning that 0.7 is not a solution to my inequality. And I'm going to shade to the right because, again, that's the way that this arrow is pointing. It's pointing to the right. And also because my answers are numbers greater than 0.7, so I'm going to shade all the numbers that are greater than 0.7. So now I've solved, set, graph. Now I'm going to check it. I'm going to go back to the original, and instead of n, I'm going to pick a number in the shaded region to plug in for n. I'm going to pick 0.8. You could have also picked 0.9 or 1. So I'm going to plug that in everywhere I see an n. And I'm going to work it out, so I'm going to say 6.7 times 0.8, and I get 5.36. And on the other side, I'm going to say 2.7 times 0.8, and I get 2.16. Then I'm going to say 5.36 minus 4.1 is 1.26 is greater than 2.16 minus 1.3 is 0.86. And that is a true statement. 1.26 is greater than 0.86. So that checks out. Make sure you have the solve, set, graph, and check before you move on. All right, number 4, I'm going to show you on notebook paper. Go ahead and write it down. Number 4 says 4 parentheses 9 plus k parentheses is less than 2 parentheses k plus 5 parentheses. So first thing I have to do here, first thing I notice that this one is different because it has parentheses. So I need to take care of those parentheses first. So to do that, I'm going to distribute what's directly in front of the parentheses that's being multiplied. So I'm going to say 4 times 9 and 4 times k. And I'm going to get 36 plus 4k is less than, and then I'm going to do the same thing with the 2. 2 times k is 2k. And then 2 times 5 is 10. And then I'm going to notice that I have k's on both sides again, so I'm going to take the one from the right and move it to the left. Again, I like to do it this way so that my k is always on the left where it needs to be when I'm finished. So I subtracted 2k from both sides. I'm going to bring down my 36. 2k minus, or 4k minus 2k is 2k, positive 2k. So then I'm going to subtract the 36 from both sides, because again, my whole point is to move everything away from the k. So I need to move the 36 and the 2. I'm going to move the 36 first by subtracting. 2k is less than negative 26. Then I'm going to move the 2. The 2 and the k are being multiplied, so I'm going to do the opposite and divide both sides by 2. This time, be careful, your inequality symbol is not going to flip here, because you're not actually dividing by a negative number, you're dividing by a positive 2. So your inequality sign is going to stay less than, and it's going to be less than negative 13. So now that I've solved it, I'm going to set it with my squigglies and my k such that. So I've solved it and I've set it. Now I'm going to graph it. Sorry about that. Solve, set it. Now we're going to graph it. So I'm going to draw my number line, put my negative 13 in the middle. I'm going to put 2 numbers less than that and 2 numbers greater than that. So I'm going to put negative 15, negative 14, negative 12, and negative 11, and remembering that negatives go opposite than positives. It's going to be an open circle because there's no extra mark underneath the less than symbol. It's just less than, and the arrow is pointing to the left. So I'm going to shade to the left. It's also because all of my answers are numbers that are less than negative 13. So I'm going to shade the numbers that are less than negative 13. So I've solved, set, graph. Finally, I'm going to check. Again, to check, you go back to the original before you did anything, even before you distributed. I'm going to say 4 parentheses 9 plus k is less than 2 parentheses k plus 5. And everywhere I see a k, I'm going to plug in a negative 14. Again, I could have also picked negative 15 to have checked with. And when I work this out, first I'm going to say 9 plus negative 14 is negative 5. So 4 times negative 5 is less than negative 14 plus 5 gives me 9, or negative 9. So 2 times negative 9. I'm going to say 4 times negative 5 is negative 20. Is less than 2 times negative 9, which is negative 18. Negative 20 is less than negative 18. So that checks out. Please make sure you have your solve, set, graph, and check before you move on. All right, go ahead and write down number 5. It says negative 2 parentheses 5 plus, or 5 minus w, excuse me, parentheses is less than or equal to 4 parentheses w plus 1. Again, this one looks very, very similar to the other one that we did. Go ahead and take a minute, pause the video, and try this one on your own. Hopefully you've had a minute to try this one on your own and you've paused the video. Let's see if you got it correct. They're going to go ahead and add the opposite here. They're going to say plus negative 1w instead of minus w. Then they're going to distribute the negative 2 and the 4. And I would prefer that you put your arrows, even though it's on the PowerPoint. We said negative 2 times 5 is negative 10. Negative 2 times negative 1w is positive 2w, is less than or equal to 4 times w is 4w, and 4 times 1 is 4. Now we have w's on both sides, so I'm going to move the one from the right to the left. So I'm going to subtract 4w from both sides, and I get negative 10 plus negative 2w, or minus 2w if you didn't do adding the opposite, is less than or equal to 4. Then I'm going to move the 10, so I'm going to start moving things away from that w. I'm going to add 10 since it's a negative 10, and get negative 2w is less than or equal to 14. Then I'm going to move the negative 2 by dividing. Now be careful, I just divided by a negative 2, so my inequality symbol is going to flip over. It's going to go from less than or equal to greater than or equal to because I divided by a negative. So I would suggest when you're working these out on your own that you always go back and check to make sure that you don't have anywhere where you multiplied or divided by a negative and forgot to flip your sign. So we have w is greater than or equal to negative 7. I solved it. Now I'm going to set it with my set notation. So I have my braces, w such that w is greater than or equal to negative 7. And then I'm going to graph. So I'm going to set up my number line with my negative 7 in the middle. Two numbers less, so negative 9 and negative 8. Two numbers greater, negative 6 and negative 5. Remembering that negative numbers are opposite than positive numbers on a number line. This time I'm going to have a closed circle because there is an extra mark underneath the greater than symbol saying that negative 7 is included in my answers. And the arrow is pointing to the right, so I need numbers that are greater than negative 7, so that would be negative 6 and negative 5. Make sure you have that graphed correctly. Then we're going to check, and again I'm going to check with the number in the shaded region. Go back to my original inequality. And instead of w, I'm going to plug in negative 6. Now be careful with your check right here because this minus and negative 6 right here, the minus and negative is going to turn into a positive or plus right here. So that ends up being 5 plus 6, which is 11 right here, so be careful with that. The two negatives make a positive. And then here, negative 6 plus 1 gives me negative 5. Then I'm going to multiply and get negative 22 is less than or equal to negative 20, which is a true statement. So make sure that you solved, set, graphed, and checked before you move on. All right, we do have a word problem for this one, but we're going to save it for class tomorrow. So we're going to save that word problem to go over in class tomorrow to kind of show you how this is used. So now we've covered our objective, which is to solve an inequality with one variable that contains more than one operation. So this is the end of your video. Thank you for watching.